The problem statement in question 3 of this exercise is as follows. In the following APs, find the missing terms in the boxes. So we have these 5 APs, but some terms of the APs are missing. For example, in the first part, we have this AP where the first term and the third term is given, but we have to find the second term. And similarly, each of the other parts have to be solved. Now, the key idea to solve each part is to figure out what the common difference of each AP is, as that will enable us to write the missing terms from the given terms. For example, if we can figure out the common difference of this first AP, then I can just add that common difference to the first term 2 and I can get the second term. So what we have to do is find the common difference in each case. Now, given any two terms of an AP, any two terms and their positions, it is super easy to find the common difference. Let me show you how in the context of the first problem. So visualize this number line of sorts which shows the terms of the AP. So we have the first term 2 which is given to us, and we have the third term which is 26, and what we have to do is we have to find the second term. Now basically, to go from the first term to the third term, you have to make two jumps of the common difference. So let's say D is the common difference of this AP. So you have to make two jumps of size D, and that will take you from 2 to 26. So that's a change of 24. So two jumps of D or 2D should be equal to 24, and this means that D should be equal to 12. And D is equal to 12 means that the second term will be the first term plus D. So the second term will be 14. So the T2, we can write this as 14. Now the same idea, the same solution can be done algebraically also. So let's do that. So in that case, we would write T1. So let's say A is the first term. So A is 2 and the third term is 26. So let's say D is the common difference. So D is what we have to find. So we can write T3 is A, which is 2 plus N minus 1. So N is 3. So N minus 1 is 2. So 2 plus 2D. So T3 is 26. So 26 is equal to 2 plus 2D. And this means that D is 2D is equal to 24 or D is equal to 12. And once again, we get the same value for D, and this means that the second term is A plus D or 14. So let's write it here. So the answer for the first part is 14. Now for the remaining parts, I will solve parts 2 and 3 directly through this number line visualization that I showed you. And then parts 4 and 5, I will solve by writing out the solutions algebraically like I did just now. And of course, both approaches are correct. Okay, to solve part 2, look at this number line visualization of the AP. So we have T1, the first term is missing, which is what we have to find. T2 is 13 given. T3 is also missing. We have to find this, and T4 is equal to 3. So imagine going from the second term T2 to the fourth term T4. So to do that, we'll have to make two jumps of the common difference, right? So D and D. So, and that will take us from 13 to 3, and that's a change of minus 10. So 2D or two jumps of D will give us a change of minus 10, and this means that D must be equal to minus 5. And now that we have the common difference D, we can easily find the missing terms T1 and T3. So T1 will be equal to T2. So we have T2 minus T1 is equal to D. So T1 will be equal to T2 minus D. So if T2 is 13, then T1 will be equal to 18. So let's write it here. So T1 is 18. And if you can verify that if you have the first term as 18 and you apply a common difference of minus 5, the second term you get is 13. And then the third term you will get is 13 plus minus 5 again. So that's 8. And the fourth term is 3, which is already given. So the missing terms are 18 and 8. And let's write it in the answer boxes. So the first term is 18 and the third term is 8. So that solves part 2. Now let's do part 3. Okay, to solve part 3, let's again use a number line visualization for the AP. So the first term is given 5 and the fourth term is given 9.5, and the second and the third terms are missing. So to find the common difference, we observe that to go from the first term to the fourth term, we will have to make 3 jumps of the common difference. So 3 jumps of size d, and that will take us from this term, first term 5, to the fourth term 9.5, and that is a difference of 4.5. So 9.5 minus 5 is 4.5. So 3d, 3 jumps of d, is equal to 4.5. 4.5 is 9/2. So this means that d is equal to 3/2. So now that we found d, the second term is simply 5 plus d. So 5 plus 1.5 is 6.5. So let me write it in a different color. So t2 is 6.5, and then t3 is 6.5 plus d again. So that is equal to 8. And then t4 is of course given to us as 9.5. So the second and third terms of this AP are 6.5 and 8. So let's write this answer. So the second term is 6.5 and the third term is 8. And that solves part 3. Now let's do part 4. As I said, for these last 2 parts, I will write out the solutions algebraically. So for the fourth part, the first term is minus 4 given to us. Now the second, third, fourth and fifth terms are missing. And now we're given the sixth term. So I can write this as t6. This is equal to 6. So an expression for t6 would be a plus n minus 1. So n is 6, so n minus 1 is 5 d. So let's plug in the values. So t6 is 6. 6 is equal to a is minus 4 plus 5 d. So we are trying to find d, and this means that 5d is equal to 10, and hence d is equal to 2. And now all the terms of the missing terms are quite easy to find. So the second term is minus 4 plus 2. The common difference is 2. So minus 4 plus 2 is minus 2. Then the third term will be the second term plus 2 again. So that will be 0. The fourth term will be 0 plus 2. So that will be 2. And the fifth term will be 2 plus 2. That will be 4. And then the sixth term is already given to us as 6. So this completes part 4. Now let's finally do part 5. So in part 5, we are given the second term, and then we're given the third, fourth, fifth, we are given the sixth term. So the first term is missing, and the third, fourth and fifth terms are missing. So let's assume that the common difference of this AP is d. So we have the second term is given to us. So t2 is 38, and we are given the sixth term, that is equal to minus 22. We don't know a and we don't know d. So let's assume that the first term is a and the common difference is d. Now, an expression for t2 in terms of a and d will be t2 is equal to a plus n minus 1d, and n minus 1 in this case will be 2 minus 1 or 1, so a plus d. And from here I can get the equation a plus d is equal to t2, and t2 is 38. Now similarly, t6 is given as minus 22, so t6 I can write as a plus n minus 1d, so 5d in this case. And from here I can get this equation a plus 5d is equal to t6, which is minus 22. Now I have this first equation, let's call this 1, and I have the second equation, let's call this 2. So what I'm going to do is subtract the first equation from the second equation. So I'm going to do by 2 minus 1. What will this give me? So on the left hand side, the a terms will cancel out and I'll be left with 5d minus d. So that's 4d on the left side. And on the right side, I will have minus 22 minus 38. So that's minus 60. So 4d is equal to minus 60, or this means that d is equal to minus 15. Okay. And now that I have d, I can plug it into any of the two equations and find the value of a. So let's plug this value of d into the first equation. A plus d is equal to 38. So a minus 15 is equal to 38. And this gives us the value of a. A is equal to 38 plus 15. So this is equal to 53. So the first term is 53. And now we have to find the third, fourth and fifth terms. So the third term t3 will be equal to a plus 2d. So this is equal to 53 and plus 2 into minus 15. So 53 minus 30, that's 23. So let's write 23 here. And then t4 will be equal to a plus 3d. So that's 53 minus 3 into 15. So minus 45. So that's 8. I'm using these formulas, but you can also calculate each term from the previous term just by adding the common difference. So for example, for T5, I can simply take the previous term, so that's 8, T4, and then I can add minus 15, so that gives me minus 7. So T5 is minus 7, and then T6 is already given to us. So this solves part 5, and with this all the 5 parts of question 3 are done. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.